We're going to see in this video how to track objects based on their colors. So for example, here I have two markers, a blue and a green one, and I want, for example, track to show only this blue marker and not show myself, or for example show just this one and nothing else on the screen. To do this, we need to configure our code to just say take this blue or take the green. And so let's start to create the code. So import CV2, import numpy as np. So we need the camera, so cap equals cv2.video-capture 0, while true, underscore comma frame equals cap.read. Then we show the frame cv2.imShow frame key equals to cv2.wait key 1 if key equals 27 and 27 is the ask key. We break the loop and we release the camera cap.release and we destroy all windows, cv2.destroy all windows. Let's see if it's all correct. Okay, correct. Now before doing any operation, we need to convert the color format. So the frame and OpenCV in general works with RGB color format. So each pixel we have a value of blue, green and red, and with these values, so each one from 0 to 255, you can create a color. But it's hard to use this, for example, if you want to change just the brightness of an image or the concentrations of the colors. So in this case we need to use the format HSV. So we convert the frame cv2.cvt color frame cv2 color underscore bgr to HSV. And to show you how HSV works, okay, this is from GIMP, and in GIMP we have two formats. We have HSV and RGB. And for example, in RGB you just choose, so we have red, green and blue. You choose how much green you want. For example, we put all the green, and this is completely green, or all the red, you see completely red, or all blue. And then if you want different colors, you can mix blue with red, or blue with green, or red with green, or all three together. While HSV will have, let's put it this way, this value hue, and here you choose the color. Let's, for example, choose the green. This is the concentration of the color, so from 0 white to 100, which is total green, and this is the brightness of the color from 0 to 100. And so it's the same for each color. You can choose this red and change it. And as you can see here on GIMP, we have the maximum value is 360, so from 0 to 260 the first value. The second one is from 0 to 100, and the third one from 0 to 100. But each software will have his own scale, and for OpenCV it will be the first, so let's call it minimum equals of course 0, 0 and 0, and the maximum will be max equals 180 the first, 255 the second, and 255 the third. Sorry, not this one, but this one. Okay. And they work the same way, they have just different scales. So now that I explain why HSV, now we need to create a range. For example, we want to detect this marker, and you can see that it's all one color, but exactly each pixel has different value because of the light and many factors. So you cannot say just take this value of the pixel, but you have to say a range. Okay, from for example this lower blue, some, let's say, really dark blue, this part is darker, to this more lighter blue. So we need to create a range, so let's do that, and it will be lower blue equals, and we need to use numpy array and p.array because, as I said in some previous video, numpy is faster than normal array, so just use numpy. And let's put the lower all the minimum value like 0 for the moment, and upper blue equals and p.array, and now we put all the maximum, so 180, 255 and 255. As we have defined this range, so lower and upper, we will use them to create a mask. So mask equals to cv2.in range So we're working with the HSV, lower blue and upper blue. And now let's show the mask. cv2.in show mask. Here the mask covers everything because we are taking all the range from the minimum to the maximum. Let's see if we change something here. Now I'm going to change it a bit random. Here you can see that some part, for example, now we are putting in the range this red on the background, and here is the blue, also a bit of the blue. So we need to adjust these values. How to do that? Now it comes really useful, the track bar, as we saw in the previous video. The track bar, so we can adjust all these values in real time. So let's create a track bar. Actually, we need 6 track bars for 6 value, 1, 2, 3, 4, 5, 6, and it will be, first we need to create the window. Let's call it let's create a window only for the track bar, so it will be better. Let's say CV2 dot name it window. Let's call it track bars, and we need to associate an image to this. Okay, first let's create a track bar. So CV2 dot create track bar. So first the name of the track bar. Right. Okay. First the name of the track bar will be lower h, so LH. Name of the window, track bars, starting from 0 to 179. So I made a mistake. Now it has 180 value, but so it is from 0 to 179, the maximum. And then nothing. Here we need to create a function, nothing def nothing x and pass. So we have the first track bar for lower h. Then let's just copy this one 5 more times. 1, 2, 3, 4, 5. So we have HSV, so we have S, V, H, again H, S, V. All the first 3 are lower and the second are upper. Upper. And here hue goes from 0 to 179, saturation from 0 to 255, value from 0 to 255, again saturation to 179, this to 255 and 255. Now we need to use them somehow. Okay, let's see what if we get the bar. Here we have our track bar. Let's see if it's alright. Yeah, of course we have the track bar, but it's not working now. So now again we need to take each value created from these track bars and use them instead of these numbers. So we will do something like this. First is lower h, so LH equals to CV2.get track bar position, the name of the track bar, so LH, and the window. And as before, let's copy this one 5 more times. 1, 2, 3, 4, 5. So we have lower h, lower s, lower v, upper h, upper s, upper v, and here the same lower HSV, upper HSV, and let's put the value here. So lower H is this one, lower S is this one, lower V this one, upper H this one, upper S this one, and finally upper V this one. Let's run the code and let's now try to change the value. So I will take the marker. Now I want to get the range only of this marker. So let's put the upper, I actually stop one moment, let's put the upper values all at the maximum already. So 179, 255 and 255. Okay. I want to get only this marker right now. And so let's change something in the color. What we are interested in now is in the mask. Okay. And we are interested in the mask, exactly in the white part. So saturation can be this range. Oh, now it's really clean. And actually also my glasses reflect the blue light, so it will be a problem. Now I will take them off. Here I consider this one a good result. So now that we created the mask, we can put the mask on the screen. So we will put this mask over the image, and all the black part will be covered, and I will show the real full color image. So I don't even need the glasses. Okay. So we have here the mask. Okay, let's create a new image. Show result. And what will be the result? The result will be equals to CV2. We can use bitwise operation here. We take the frame, again the frame, and we put our mask equals mask. And let's run it. Okay, now the value of course I stopped the code, again start to default, but again no problem. Let's do the same work as before. No. And you can see this one. I have also the green, now it's working a little bit. And now I'm doing it for the green. Of course it's different for the green and for the blue. Even it's strangely, okay, it's working for both. But usually when you want to take different colors, you need to create two separate masks with their own values. So we will have one just for the blue and one mask just for the green, and then you can combine them together. And that's all for this video.